Hello guys and welcome back to another class of our course about the complete introduction to data science. So in this class, this will be our last class about statistics, and in today's class the main topic would be probabilities. So we are going to talk about what exactly are probabilities, where they're used, and some of the formulas that you guys can find in probability. We're not going to go too much in depth in those formulas because just the concept of statistics and probability, just the concept of probability could be a complete class of at least 45 hours that we can talk about all the functions that are implied, how to use those functions, and many other things. So I'll try to be as brief as possible and give you a brief introduction to this topic. So let's jump right into it. So basically, what exactly are probabilities? In this case, probabilities are the measure of likelihood that an event will occur in a random experiment. So basically, it's just the probability of something happening. So let's say, for example, you are playing with a $1, so a piece of money. And what are the chances that when you throw that piece of money, it will fall on a head, so on a face, so it will fall on face. So you will have 50% of chances that this piece of money, if you throw it, it falls on face. So basically, those are the probabilities, would simply be the odds of this happening in that case. Probabilities are used in many places, not only in data science. Well, it's really a huge part of it, but it can be used in many places. So basically, it's simply calculating the odds of something happening. So one of the major places where this is used is casinos. So basically, when you're going to the casino and let's say you are playing a game, why the casino always win? It's because you have statisticians that have studied the game, that have created a game that gives the casino an advantage on the long run. So yeah, sometimes the casino might lose money on the short run. So you come here, you play, you win, you go home. But on the long run, on let's say 100 plays, 1000 plays, the casino will always be positive. So basically, that's the goal of the casino, being positive on the long run. So basically, where exactly probabilities are used, it can be used in many places, as I said. So the first one would be games of chances. So in this case, everywhere where you need to gamble. So it could be sports, it could be, I don't know, it could be, for example, casinos, it could be lottery, it could be all the places where you have to gamble. So once again, if you don't imply a mathematical calculation and you just speculate on a certain outcome, those would, well, you will include probabilities in it. If you start calculating and including maths, it's no longer gambling. Second place, the weather prediction. So basically, for those who don't know how exactly works weather prediction, so you have someone that will analyze analyze some things. For example, looking at clouds, looking at the sun, and some other variables that I know nothing about. But they will analyze some variables, and by analyzing those variables, they will be able to make a prediction based on many variables. Once again, this prediction is never 100% sure. It's only based on past experiments. This is why the weather is not always accurate. But based on past experiences, the weatherman is able to say, hey, tomorrow we will have a sunny day, and we have 30%, we are 30% sure that it's gonna rain. But once again, it's just 30%. And once again, it will predict based on different variables. The third part would be finances. So for everybody who is speculating on the financial market, probabilities are really a huge part of it. So to be able to calculate the risk that the person is taking, so just putting the risk as a number, it's really important. Well, putting it in a number and understanding it, understanding how much profits you could be able to make, understanding all the variables that are around the financial investments, require a lot of probability knowledge. After that, mathematics, since statistics and probabilities are part of statistics that are part of mathematics. Of course, mathematics, have a lot of probabilities in them. It's a part of it. And finally, any other place where you are required to make provisions, and you are required to speculate on something that will happen or no. Second part, what we are going to talk about today will be the type of events. So basically, in probabilities, you have two types of events that can happen. So you have disjoint events and, once again, non-disjoint events. Basically, the difference between both of them is that one will include two variables. Well, the first one will be disjoint event. So if two events cannot both happen at the same time. So basically the first one will include that two events can't happen at the same time, and the other one will be able to let you have two events that happen at the same time. So if we start with the first event type, so the disjoint event, so a good example that we can have is the one that I wrote right here. So the probability that we get 1 and 2 simultaneously by rolling a dice. So let's say you have a dice in your hand and you throw that dice. Is it possible to have 1 and 2 at the same time? No, it's not possible, because you only have one dice, and it's possible to have a 1 or a 2. So this would be a disjoint event because you can't have those two answers at the same time. But let's say right now you have two dices and you throw them, and you throw those dices and you have a 1, and you can have a 1 and a 2 at the same time, because the fact that the dice number 1 falls on 1 is not dependent on the dice number 2 that falls on number 1 or number 2 or whatever. So there is an independence between the two things that are thrown, in this case the dice that are thrown, and this independence makes it a non-disjoint event. So basically disjoint event, there is a dependence between the two events. So if we throw one dice, it will have a dependence. So the fact that it falls on 1 make the dice will create a situation where the dice can't fall on 2 because it already fell on 1. But on the non-disjoint event, if we throw the two dices, the fact that the dice number 1 falls on 1 doesn't make a situation when dice number 2 can't fall on 1 or 2. The dice number 2 will fall on 1 or 2 or whatever. So there is no dependence between two dices. So here you can have an example of it. So you will have mutual exclusive events that will be disjoint events, and you will have non-mutual exclusive events that are non-disjoint events. And basically the difference, as you can see, so A and B can't happen at the same time, and here A and B can happen at the same time. So in the non-disjoint events, it's possible to have them happening at the same time. Next thing that we are going to talk about today will be the types of probability, and basically in this case we have 3 types that are very important that we are going to talk about. So we have the marginal probabilities, we have conditional probabilities, and finally we have joint probabilities. The first one, that is the marginal probability, is pretty simple to understand. It's simply the odds or the probabilities that something happens right now or happens at a certain moment. So basically, let's look at this example. So the probability of drawing a black card in a deck of cards. So let's say you have a deck of cards right now, and you take a card. So the probability that this card would be a black card. Basically, half of the deck is black, half of the deck is red, so you will have 50% of chances of taking out a black card. So basically, this would be an example of a marginal probability, the probability that something happens right now on the spot. Second thing would be conditional probability. In this case, that will be the probability of an event occurring when another event has occurred. So basically, let's say something happens. Let's say you have drawn a certain card. So like in the example right here, you have drew a king in a deck of cards. And then this king, what are the odds that this king would be, let's say, red? So would be a red card. So once again, the chances of this king being a red card would be 50% because you have 4 kings, you have taken away a king, and the probability of this king being red would be simply 50% because you have 4 kings, 2 red, 2 black. But in the other case, if let's say, for example, you have taken out a red card, what are the odds that this red card is a king? Well, in this case, it's a bit more different because you have 52 cards in a deck, so you will have in this case you will have 26 cards of each, so 13 cards that are red. So the chances of you having a king in those 13 cards would be 1 on 13. So once again, this is a fraction, but it's gonna be something like 7%. So you will have 7% of chances that this card that you just took out would be a king. Alright, so the final one, the joint probability, it's looks like the conditional probability. You will see it's pretty much the same thing, but there is a small difference between both of them. So the joint probability is the probability that two events occur at the same time. So what are the probabilities that you drew a 1 and a heart in a deck of cards? So basically, what are the probabilities that you drew a 1 heart in a deck of cards? So basically, this probability would be 1 on 52 because there is just one heart, so 1A. In this case, it's gonna be A. What the ace? So basically, in this case, it's going to be 1 on 52 because you only have one ace of heart inside of the deck of cards. If the probability of you drawing a ace of red, so in this case, it's gonna be 1 on 26. So the probability of you drawing a ace red, it's gonna be greater than the probability of you drawing a ace that is of heart. So basically, this is the difference between the conditional and the joint. So basically, the conditional will happen if an event occurs, the probability that another event occurs as well. So this would be the conditional. So something happens and then you are looking at the probabilities that something else happens. So it's basically two probabilities, and in the joint probability, it's like putting those two probabilities together. So basically, let's take once again this example right here of the king. Let's say you took a king of your pack of cards. In the first case, you will calculate the probabilities of you drawing a king. Then you will calculate the probabilities of you drawing a red king. So in this case, that you drew a red card as well. In the joint probability, you will simply calculate the probability of you drawing a red king. So this would be just this calculation that will be made. So this is for the type of probabilities. The last thing that we are going to talk about are the probability distributions. So once again, this is the part of the course that takes the most of time because there is a lot of formulas. They pretty much look like this. So as you can see, basically what you need to understand, we're not gonna go through each of the formulas, through each of the functions, but what you need to understand is that the probability distributions are a function that describes the likelihood of obtaining a possible value that a random variable can assume based on different criteria. So basically, you have a situation that happens and you want to calculate the odds of something happening. So how exactly do you calculate it? So you'll need to take all the variables in consideration, and based on the situation, you will have to use a certain function. So you will not use the geometrical function at the same time that you will use the Bernoulli function, for example, or the binomial function or the Poisson function. All those functions are based on different situations and are based on different type of events. So let's say, for example, if you have a situation where you, I don't know, draw cards, for example, from a deck, and you put them back inside of the deck, and you want to have the probability of you drawing 2 times the same card, you will not use the same function that if you don't put back the cards in the deck. So basically, you will use 2 different functions, because in the first situation, you took the cards from the deck and each time you put them back inside of the deck. And in the second situation, you didn't put the cards back inside the deck. So there is, depending of the situation, you will use different probability distributions, so different functions. So this is what you guys need to understand about probability distributions. Once again, there is a lot of them, and to become, more advanced and understand them all, you need to practice. So if you guys are interested, I highly suggest you to just take a statistics course, and you will have everything that you need inside of it. Especially if you want to know a bit more about those functions. So basically what we talked about inside of this course are probabilities in, we talked about probabilities, we talked about types of event, we talked about different types of probabilities, and finally probability distributions that are this part of the course. So this, as I said, the statistical part of this course can easily be done in at least 2 university level courses. So it's really complicated. I try to make it as easy as possible for you guys to understand it. So once again, this is just an introduction to it. So I hope you guys liked it, and if you liked if you like the statistical part and want to get to understand it a bit better, I highly suggest you to take a statistical course or just to practice a little bit, and you'll see it's not that hard, it's not that complicated to understand. It's just a question of practice. So that's it for this last course about statistics, and see you all in our next class.